Welcome to Study Loop.
Well, welcome back. We're still in chapter 13, but we've moved on to problem 42. And if you're a sci-fi fan, it is the answer to the universe. All right, let's look into this. A solution is made containing 20.8 grams of phenol, and they've given us the molecular formula, in 425 grams of ethanol. So just to recap, grams of solute, grams of solvent, and grams of solution. So which one's our solute? If you said our 20.8 grams of phenol, you'd be correct. And the reason is it's the smallest. Solute is always the smallest. Solvent is what it's dissolved in. That's the larger amount, the 425 grams. And the solution is made of both. It's very important to remember that the solution is both the solute and solvent together. We're just going to add them up real fast and put that off to the side before we start looking at how to start answering questions. Just a quick recap there. 445.8. All right, they want us to calculate the mole fraction of phenol, the mass percent of phenol, and the molality of phenol. So phenol is here. So that's our solute. So that's awesome. We've already looked at what we should be looking at on here. So whenever we need the mole fraction, this has to be in moles. So unfortunately, we're going to have to go through and convert. We've got 20.8 grams of phenol, which is C6H5OH. All right, how do we convert things from grams to moles? If you said periodic table, you'd be absolutely correct. So let's see what we have. Carbon on the periodic table is 12.01, and we have 6 carbons. And we have 6 hydrogens. So let's look on the periodic table. Hydrogen is 1.01 grams per mole, and we have 1 oxygen. So that altogether calculates out to a molar mass of 95.07 grams for every 1 mole. So let's convert that phenol now. So 20.8 grams divided by 95.07 gives us a molarity, or just a mole, not molarity, 0.188 moles of our solute, which is the phenol. All right, let's look at how many moles of ethanol we have. 425 grams of ethanol, and thankfully they gave us the formula, so you didn't have to memorize what ethanol is or go look it up in a chart in your textbook. We will have to look up, however, how to convert grams to moles. And since we're using our periodic table, it is always to 1 mole. All right, let's see what we have here. We have 2 carbons, and the periodic table tells us that carbon has a weight of 12.01 on average. And how many hydrogens do we have? 3, 4, 5. And the periodic table tells us it has 1.01. And we have 1 oxygen, which is 16 grams per mole. Altogether, that's going to give us a 45.07 grams per mole. So let's find out how many moles of our solvent we have. 425 divided by 45.07. If you got 9.43, then you did excellent. Moles. The reason we converted this to moles is because A asked us for the mole fraction of phenol. And how do we get a fraction? The fraction, mole fraction, is always chi. We know that the fraction of phenol plus the fraction of our ethanol will equal 1. And that's something we tend to use more for gases. One of the other ways that we can do that is we know that the fraction of phenol and ethanol together equal 1. So let's add them both up. This in here. So we know that our chi C6H5OH is equal to 2188 moles over the solute plus the solvent, our solution, which is 0.2188 plus 9.43 moles and moles. All right, let's put that in our calculator and find out what we get. 0.2188 divided by 0.2188 plus the 9.43 gives us a molar fraction of 0.0226. And let's look. We had 3 significant figures in each one of them. So we're going to have to round. So we'll have 0.0227. Perfect. That is our part A, molar fraction. Part B, we're looking at the mass percent of phenol. Do you remember the mass percent formula? Mass percentage is equal to the solute over grams of solute over grams of solution times 100. So let's look at what we have here. Our mass percent is going to be equal to grams of solute, which we found initially was 20.8 grams. And then our grams of solution is 445.8. And we times that all by 100. And that will give us the mass percentage. So let's put that in our calculator. 20.8, we're going to divide that by 445.8. Remember to times it by 100. And you find that we have 4.67 mass percent mixture. All right, now we're on to C, molality. So molality is the small m. And what are the units of that? So take a moment and think. This will come up on several of your tests. So every time I want to practice going over what units. So it's always moles per kilogram. Perfect. We have already solved for moles of our solute. So we know that we have 0.2188 moles of our solute over kilograms of our solvent. Our solvent's right here, 425 grams. We need it in kilograms, so we're just going to convert it off to the side here. Kilograms go on top because that's what we want, and it takes 1,000 grams to equal 1 kilogram. So we put that in our calculator, and what do we get? 425 divided by 1,000. Or if you prefer and you've been taught to just move the 0, that's perfectly fine as well. Both end up with the same answer of 0.425 kilograms. So let's look over here. 0.425 kilograms. All right. So now all we have to do is put it in our calculator and find out what our molality of phenol is in this solution. We find out that that is 0.514 8. Let's look at we were given 3 and 3 significant figures, so we're going to have to round this. It's very important to remember significant figures, especially on your exams. So it's 0.515. And don't forget your molality symbol, which is a small n. All right, so we've solved part A, which was the mole fraction of phenol. Right here, we used our mole fraction information. B was our mass percent. We used our mass percent formula. And C is molality. So remember on tests to write down the formulas before you start. And you're sure to get some extra credit, or not extra credit, but partial credit, even if you put all the numbers wrong in your calculator.